So good morning, good afternoon, and good evening, and dear colleagues. So welcome to the second day of the side events of the 53rd session of the UN Statistical Commission. So this side event is focusing on adopting a systematic approach of using small area estimation for SDG monitoring. My name is Yung Yiming, and I'm the Chief of SDG Monitoring Section at the UN Statistical Division. So leaving no one behind is the central transformative promise of the 2030 Agenda for Sustainable Development. It recognizes that the dignity of the individuals is fundamental, and that the agenda's goals and targets should be met for all nations and people and for all segments of the society. Ensure that these commitments are translated into effective action requires a precise understanding of the target population and progress made in addressing their particular priorities. To properly measure this, statistics and data need to be presented for different population groups and geographical areas. So small area estimation techniques have been proved to be very useful in providing reliable disaggregate data for some of the SDG indicators, such as poverty estimation, food insecurity, and on the nutrition health-related indicator and unemployment rate, etc. So this side event will share our national experiences in using small area estimation methods for SDG and monitoring, present latest methodological development in small area estimation, and identify steps required to establish a sustainable small area estimation system within National Statistical Office. So we will hear from 5 experts from national statistical offices, regional commission, and international organizations that share their experiences and latest work in these areas. So without further ado, I would like to introduce our first speaker. Our first speaker is Ms. Margaret Ari Angorawati. She is a coordinator and the subdirector of statistical consistency of Statistical Indonesia. Ari will present small area estimation modeling for SDG indicators in Indonesia. I will pass the floor to you, Ari.
Thank you, good morning, everyone, ladies and gentlemen. Greetings from Indonesia. My name is Margaret Ari from BPS Statistik Indonesia, and thank you for UN for this opportunity for us to present our research. Okay, next. Yeah, okay, next. Yeah, this is BPS Statistik Indonesia as a national statistic office support the successful implementation of the Sustainable Development Agenda by providing data that can be used to support the SDGs Indonesia. The process of producing the data by carry out through the regular survey. However, the implementation of the survey is not able to directly produce the required SDGs indicators. And we have a problem, that is the lack of sample of indicators for the estimation. It caused the estimation result will have the low precision in some cases. And we can have a solution, increase the samples, but it will be timely, higher cost, and need more human resources. So we propose the small area estimation as a solution. Yes, next, please. Yeah. Yeah, this is the small area estimation, the definition, and we have doing some research with the EBLAB, hierarchical bias, and SI with measurement error. Yeah, and the target indicators, we doing 11 indicators in 2021. Yeah. This is the first indicator is the percentage of children with below 18 years old, living below the poverty line, and then percentage of infant aged less than 6 months who get the exclusive breastfeeding, and then the proportion of ever married women aged 15 years old to 49 years old whose last delivery was assisted by trained healthy personnel. And fourth is the proportion of ever married women aged between 15 years old to 49 years old who last delivery was in a health facility. And the fifth indicator is the percentage of children aged between 12 to 23 months who receive a complete basic immunization. And six is percentage of mother who delivered live-born children in the last 2 years and the last with low birth weight. And the seven is gross enrollment rate for early childhood education. And the eight is percentage of children aged between 25 to 59 months who have participated in the early childhood education program. And then the 10 in education completion level for primary school.
I think we lost her.
Yes, she was having issues. She said earlier it was raining hard there.
Oh, okay.
I'll look out for her in the lobby.
Yeah, maybe just 1 minute. If not, we can switch to the second presenter. Okay.
Let me text.
Yeah.
Just text her.
Maybe while waiting for her, and I'll probably let me see. We can invite the second speaker to go ahead first. So our second speaker is Miss Veronica Canales. She's a sociologist and research analysis at the Ministry of Social Development in Chile. She has been in charge of the production of a small area poverty estimation since 2019. In her presentation, Veronica will share small area estimation for poverty at the communal level in Chile. I think the floor is yours, Veronica.
Thank you. Hello everyone. My name is Veronica and I work for the Social Development Ministry. Chile's official data source for poverty statistic is the National Socioeconomic Characterization Survey, also known as CACEN. The survey is representative at the national level, but is not suitable for disaggregation at the communal level, which is the smallest administrative division in the country. CACEN has been sponsored by the Social Development Ministry every 2 or 3 years since 1987. And the ministry is legally required to produce poverty rate estimations for all comunas. This is used to allocate funding to municipalities. Since 2011, the ministry has implemented a small area estimation method for poverty rates at the communal level, choosing an area level model. The last release of communal poverty estimates was on last November, and they were based on the 2020 survey round. The ministry signed a cooperation agreement with ECLAC in which the Statistics Division will give technical advisory to update the SAE methodology used in Chile. The main improvements in the SAE procedures were, first, a selection of quality indicators to evaluate the direct estimate used in the Fay-Harriot model, the estimation of sampling variance through a generalized variance function, and finally, the estimation of the mean square error using a parametric bootstrap. We will go through each of these improvements after reviewing the Fay-Harriot model. Survey estimates are not built to provide accurate estimation for many of the needed disaggregation for measuring progress in overcoming poverty and other SDGs. Small area methods increase the accuracy of these estimations by borrowing strength from auxiliary variables and from other domains. In the case of poverty rates in Chile, the model used is based on the Fay-Harriot model, which is a two-level model. The first model relates the parameter of interest to known auxiliary variables for each of the comunas that constitute the partition of the whole population. Since the parameter of interest is unobservable, a direct estimator is used, which carries a sampling error and is expressed in equation 2. We can combine these two equations in just one equation, which is represented below. And typically, normality assumptions are used at both levels. The approach requires that the sampling error variance of the direct estimates is available or no. However, in most of the cases, they have to be estimated based on sample data. With some algebra, the model can be expressed as a weighted average of the direct estimator and a regression synthetic estimator. In this equation, the gamma hat corresponds to the direct estimator weight. This factor puts more weight on the direct estimate when the sampling variance of the domain is small. Areas for which no direct estimation exists because the sample size is 0 are called out of sample domains, and for those areas, the prediction is equal to the synthetic component. It's fundamental to know what are the data requirements to apply this approach. To increase the accuracy of the estimate using small area techniques, it's necessary to have auxiliary information correlated with the variable of interest, but also it's important to have reliable direct estimates. We said that the approach requires that the sampling error variance are known, but in practice, sampling variance are unknown and are estimated from the survey data, which means they are subject to errors. Additionally, the model assumes that the sampling variance estimates of the target domains are unbiased and consistent. The last data requirement is less documented in the literature. However, sampling variances play an important role on the construction of the Fay-Harriot estimator, and their error must be taken into account. Sampling variances are an input for the estimation of many of the parameters of the Fay-Harriot model, like the beta coefficients, the random effect, and the direct estimate weight. Having these considerations in mind, we select 4 quality indicators to evaluate the direct estimates to be used in the production of a small area estimates. The sample size, the degrees of freedom, the number of people that have the characteristic of interest, and the design effects. To select these indicators, we use as a starting point the indicators used at the National Statistical Offices to decide when to suppress inaccurate survey estimates. The thresholds used in that context were adapted to be used for purposes. The indicators selected altogether are a measure of how well the collection process followed the planned sample design and how well the direct estimates measure the poverty situation at the comunas in terms of their point estimates and their variances. With ECLAC, we elaborate a decision tree to evaluate the direct estimates. The comuna estimates which don't meet the conditions are considered as out of sample domain and are excluded from the model. I'd like to draw your attention in only two conditions in the decision flow: the value of the design effect and the threshold of 2 or less degrees of freedom. After evaluating the first condition in the decision tree, direct estimates with an estimate design effect less than 1 are excluded from the model. A value less than 1 is not consistent with a survey which has a stratified multi-state cluster design. A value less than 1 will mean that the complex design is more efficient than a simple random sample, which is not expected due to the effect of clustering. The second condition I want to draw your attention is the lower bound for the degrees of freedom, and I will present this with an example of two Chilean comunas, Camiña and Vitacura. Camiña and Vitacura in 2017 had a zero poverty estimate. However, if we compare the degrees of freedoms, there are important differences between them. Camiña only has 1 degree of freedom and Vitacura more than 80. The degrees of freedom are a measure of how many independent primary sampling units are considered in the inference process. In the case of Camiña, the estimation is elaborated from an insufficient number of units. In the case of Vitacura, several units provided information on the variable of interest to produce the estimation. So the quality indicators allow us to detect cases to be excluded from the model. Their inclusion could lead to undesirable consequences for the small area estimations. For example, a survey estimate could seem very precise with a small variance, but it can only have 1 or 2 degrees of freedom. If we include this estimate, the model will give more weight to a direct estimate, which is not reliable. The second improvement I want to talk about is related to the direct variance estimation. The third variable of interest in the case of Chile is the proportion of individuals under the poverty line. When working with proportion estimates, it's necessary to resolve two main issues to apply the Fay-Harriot model. First, there is a high variability of the sampling variance estimates. Sampling variances are often noisy due to small sample size. Second, there is an endogeneity problem, meaning that the sampling variances are related to their corresponding proportion estimates. The first issue is resolved using a generalized variance function. This method is commonly used to produce smoothed estimates of sampling variance, producing more stable estimates than the direct ones. And the second issue is tackled using the arcsine of the square root transformation. And here, with this transformation, the variance for the transformed estimate is exogenous to the point estimate. So here, the graphic shows the comparison between this sampling variance and the estimated smoothed variance. The blue line represents the predicted variance with the generalized variance function, which describe a smaller line than the red one, which is the direct variance. It's observed that comunas with higher sample size tend to have very similar values on the estimated variances. The last improvement I want to talk about is the mean square root estimation. This is the most common measure to evaluate the uncertainty associated with a small area model. For the last publication of the poverty estimate, we use a parametric bootstrap, which allow us to estimate the mean square error and to estimate confidence interval for all comunas. To apply this procedure, we use the R package MD. And the equation below expresses the bootstrap mean square error. Using the estimated mean square error, we also obtain a relative measure similar to the coefficient of variance to evaluate the quality of the Fay-Herriot estimates. And also, given the theoretical distribution of the Fay-Herriot estimator is normal, it was possible to estimate the confidence intervals using a more simple approach expressed below. So here is a comparison between the relative root mean square error with the direct coefficient of variance. The red line is the relative root mean square error for the Fay-Herriot estimations. We can see the significant gain on precision in the sampled areas, and we also have a measure of uncertainty for those areas which are out of the sample. Finally, here's a map of Chile with the poverty rates for each of the comunas. The comunas in yellow are those with the lowest prevalence in poverty, and the comunas in red are the ones with the highest poverty rates. Because it's difficult to observe the difference in the comunas, I have separated the country in 4 arbitrary divisions, from north to the extreme south. For example, the first graph, it's the north of Chile. So we can see the north of Chile concentrates a group of comuna with relatively high poverty estimates. And that's all from my side. Thank you very much.
Thank you so much, Veronica, for sharing the methodology with us, and also particulars, a lot of the technical details. Really interesting in that quality indicators are used for the estimates. So I see Harry is back. Hi, Harry. So we will go back to your presentations. I think you stopped at that, I think the previous slides.
Yes.
Oh, yeah, at this slide. Maybe you can start from here.
Yeah, thank you, Youngie. I'm sorry for the lag connection from my country. Ladies and gentlemen, this is our target indicators in 2021. We have 11 indicators. There is percentage of children below the 18 years old living below the poverty line. And then the last is a proportion of children under 5 years of age whose births are registered by civil registration institution. So the next, this is the observation unit. According to the indicators, we have 11 observation unit, and we have 514 level estimation. This is the level estimation is regency, and we have 514 regencies. Okay, next. This is the stages that we already done in our estimation. First is preparation, the identification of data availability, and then we also have study literature. And the second stage is data setup. We set up live estimation data and set up data auxiliary variables. And the third SAE pre-modeling, we're doing data exploration, variable selection, and identify the appropriate SAE model. And then the fourth stage is SAE modeling. we did the SI modeling, check the RSA, and then we have the result analysis. And the last stage is the compilation report. Every sub-team will preparation the report and be compiled for the final report. And the approach of the SI model is SI block, measurement error, hierarchical bias beta, and then the SI with transformation and SI with clustering. Yes, next. This is our data sources. We use the Susanas is a survey that describes the basic socioeconomic characteristic of households and household members. And then the village potential data, we call it PODES. And then this PODES, this census is describe the village characteristic. We also use the other data, other survey, and map and data administration. Yes, next please. Yeah, this is data characteristic that we have non-normal data distribution. We can see that a little bit skew our data characteristic, and then we have non-linearity data, and we have ensemble observation, especially the remote area. We cannot have the sample. Yes. Next, please. Yes, this is data condition at glance that we have 19 regions have the RSA above the 25% and overall for all indicators. And this RSA problem mostly occurs in eastern of Indonesia. So the east part of Indonesia is a very difficult area for us. And the second is there are areas that are unsampled, especially for remote area, and this RSA of the estimate unable to be generated. Yeah, this make the RSA of the estimate unable to be generated. And the third is some indicators are not normally distributed at the national level, so that another SI model is used and regional grouping is carried out. So we make a group by island and etc. Yes, next please. Yes, this is the example of our analysis result. We can see the plot and also the value in the right bottom right. We can see the table that show the regencies. We have 514 regencies, and with direct estimate we have the 305 the regency that has RSA below the 25%. And with IBLAP, SAE IBLAP, we increase the better result with the RSA below the 25%, increase to 348 regencies. And with hierarchical bias, estimate with hierarchical bias, so we increase more to 432 regencies that have RSA below the 25%. We also can see the RSA up to more than 40%. With direct, we have 38 regencies, and with the IBLAP, we can better have decrease to 23. And with hierarchical bias, we have 0 regencies that has RSA more than 50%. Yes, next please. This is another example for the indicators proportion of ever married women. It's 15 to 49 years old, whose last delivery was assisted by a trained health personnel. We also can see the table that the RSA below the 25% with direct estimate 505 and increase to with IBLAP to 514. Yeah, and then with hierarchical bias 511. So IBLAP better than hierarchical bias for these indicators. Yeah, next please. Yeah, this is the result modeling, the comparison, direct estimate, and all the SI modeling. SI modeling means that this could be IBLAP, could be measurement error, and could be hierarchical bias. Yeah, this is the comparison. All of you can check again from my presentation. Next, please. Yeah, but we have a problem with the indicators number 6, the percentage of children aged between 24 to 19 months who have participated in the early childhood education program, that it showed that the direct estimate better than SIA. So we still have homework exploration for these indicators, and we plan in this year we can expand to getting involved the spatial factor in SI modeling. Yes, next, please. Yeah. Yeah, this is the 11, the result of the 11 indicators, yeah, that we already estimate in 2021. Yeah, next, please. Yeah, this is the result modeling. The note we can mention some point that the increased precision. The result from SIA showed that the RSA from their estimate is high then and can be reduced by SIA, so that more area have RSA below the 25%. So we can have the better result estimation. And the second is estimation in the non-sample region. Non-sample area cannot be estimated using direct estimation. And we can estimate by using clustering. Yeah, next. And we did a ground check as a validation of our estimation. The objective of the ground check is to check the suitability of variables and comparison between regions. So we come to some area in Indonesia and check with a focus group discussion to validate our result estimation with SI. And the method is focus group discussion with the city government, and then we come discuss with in-depth interview with the local government. So we come to a very small village to check the value of the estimation. And the result, the majority of informant thinks that the auxiliary variables used in SIA modeling are quite appropriate to use. But there are still some differences of comparison between regions based on SIA modeling result and local government information. Yeah, next. Yeah, this is the opportunity for us next in SIA modeling. First is additional data. We will optimize the utilization of explanatory variables from other data to improve estimation precision, especially for sectoral data. And then the spatial factor. It is worth trying to incorporate spatial information to SIA modeling. It is very important with the characteristic of Indonesia, that a very big country and separate by different island. And then the third is ground check. It is necessary to validate and verify the current small area estimation modeling result through the method ground check appropriate. So after the ground check last year, we still try to develop the best ground check method. So it could be a very accurate for validate our estimation with SI. And then data consistency with BPS official release. This is the further validation is needed regarding to the estimation result to be consistent with official BPS release at the provincial and national level. So we have to check the estimation in provincial level and then with a national level. Yeah, next. Yes, I think that's all from Indonesia. Thank you, Yang Yi.
Thank you so much, Ari. It's so impressive to say that Indonesia has applied the SAE method for 11 SDG indicators, and also thank you for sharing that the different stages, the step in applying the SAE method. I would like to just let everyone know we will save the Q&A session until the end because we have 3 additional speakers. I would like to encourage you to write your questions in the chat, and in the meantime, if the presenters can answer the question in the chat, please go ahead to do so. And without further ado, I probably will invite our next speaker, Ms. Andres Gutierrez Rojas, from the regional advisor from ICLAC Statistical Division, to make the next presentation. Andres will present on poverty mapping in Latin America using unit level models. Andres, you have 10 to 15 minutes. Over to you.
Thank you. Can you hear me and can you see my screen?
Yes, we can see your screen.
All right, thank you so much for having me here in this site event. I'm going to talk to you about Leave No One Behind and how the United Nations Economic Commission for Latin America and the Caribbean has developed this systematic approach to poverty mapping using unit level models. First of all, the reason why we are developing this smaller estimation system is because we are engaged with the SDGs and of course, as an economic commission, we are monitoring, assessing countries and making a follow-up to the SDGs and the related targets and indicators. Let's focus on poverty. So we have this first goal, end poverty in all its forms everywhere. And here we have two targets by 2030, eradicate extreme poverty for all people everywhere. And the second target is to reduce at least by half the proportion of people living in poverty. And note, please, that here this target says something about disaggregation. It recalls us that we have taken into account men, women, and children of all ages. That means that we need to measure or try to estimate poverty and income in these disaggregations. And of course, there is this like mandate, leave no one behind, in the 2030 agenda that says that sustainable development goals indicators should be disaggregated by income, sex, age, race, ethnicity, migratory status, disability, and geographic location, in accordance with the fundamental principles of official statistics. That says that we need to take into account not only the whole indicator at the national level, but the indicator disaggregated by these subgroups of interest. And of course, as my colleagues have said, sample surveys cannot achieve this kind of disaggregations. So we have developed a system that takes into account surveys and censuses, taking advantage of the work that have been done here in the Economic Commission for decades. The first input we take into account is the ECLAC BADEOC. That means Household Survey Databanks, that in Spanish is Base de Datos de Hogares, Household Survey Databank. And this is the main input for harmonized social indicators. It was developed in the 90s, and it collects annually household survey data from 18 countries around the region. We gather household surveys that measure actual income, and with those surveys, we estimate poverty and social indicators, and of course, something about inequality. We have surveys from 1980 onwards, and we collect one survey per year per country in the region. And the other data bank is called CELADE's Census Data Bank. CELADE is the ECLAC Population Division. And they have developed a comprehensive census data repository, something like BADEOC, but at the census level. So CELADE has pursued its activity of disseminating widely the census information derived from its data bank from many years ago. And most countries in Latin America and the Caribbean share their databases, and CELADE gathered the information. And this is an effort to decentralize the information, and it's a kind like a democratization of access to census microdata. And CELADE has developed this software. It's called Redatam. Redatam is a software for specialized in census. It is a software for statistical processing of census data. It is also like a database management tool, and we use Redatam along with the census data from CELADE in order to gather that or integrate that information of the censuses with the information from the household surveys. So let's talk about a little bit about some smaller estimation methodologies in ECLAC. This is like a map. This is an adaptation from RAMA about all kinds of methodologies that have been developed over the years regarding a smaller estimation. Here we have the direct estimation. If you have a large survey with large sample sizes across all your disaggregations of interest, this can be enough in order to estimate social indicators in your subgroups. But that is rarely the case. So we need to integrate household surveys with some other kind of information. In this case, we are taking into account not only household survey data, but census data. So here we are located right here in the unit level models. Also, we have also studied area levels or generalized linear mixed models, and we actually provide technical assistance to countries on these topics. But the methodology that we have chosen to achieve this approach is the unit level model with the EVP technique. So I'm going to talk about the unit level models and the details behind this system. So we have studied several unit level models, but we are more comfortable with this GMR model that stands for Guadarrama, Molina, and Rao model that was proposed in 2018. And it induces an approximation of a best empirical predictor based on the classical model with nested errors. But here is the paper of the GMR. And the model is can be written in this way, where weight DI star stands for the income of the person that is related with some fixed effects here and with random effects, and of course we need to take into account the errors in the model. So this is like the classical nested error models. Here we take into account that we need to transform the data because of income is highly skewed. So we need to make a transformation in order to guarantee that the behavior of the errors follow a normal distribution. But here I want to emphasize that here in ECLAC, we are devoted with normalization, with harmonization, with standardization across 18 surveys. So here you can see that our response variable is, of course, function of the income that is divided by the poverty line. And this poverty line, I want to take to go deeper about this poverty line. So the poverty line is computed for 18 countries in the region. That means that we have a comparability approach that allow us to guarantee that all our estimates are comparable across countries. So three definitions quickly. The extreme poverty line is the cost of the basic food basket that is computed by ECLAC, and it is updated on an annual basis. The relative poverty line is the multiplication of that extreme poverty line by the Orshansky coefficient that is computed by ECLAC, again for 18 countries. And the Orshansky coefficient denotes the cost of non-food goods and services, and it is estimated from household surveys as the ratio between total spending and food spending. And of course, a person is considered poor or extremely poor if the household income falls below ECLAC's poverty line, extreme poverty line, or relative poverty line. Having said that, we use a weighted approach. That means that here in the expressions of the predictors, we incorporate the sampling weights here and here in Y and X in order to avoid some possible bias. And this is like the difference with the Molina and Rao 2010 approach. And of course, we need to carry out this Monte Carlo estimation in order to get model errors. And finally, this is important, we consider a benchmarking methodology at the end of the process. That is, it is devoted with maintain consistency between ECLAC poverty figures for Latin America with this smaller estimation approach. So we have adapted a calibration approach that is the calibration approach is a technique based on the survey data analysis, but we deal with calibration as an optimization problem. So we get this kind of weights, WK for income and WK for poverty or extreme poverty. It is desirable that these new sets of weights are located around unity. That means that our model is performing good. So we benchmark our estimates for gross domains like region, sex, or area. And here are some maps. First of all, I need to say that this approach is or takes into account several stages or topics ranging from statistical modeling to sampling and survey analysis, of course, some optimization, and finally, geographical information systems and mapping. As far as we know, this will be the most extensive effort currently accomplished for the poverty mapping of a large region. I am specifically talking about the estimation in 18 countries of Latin America. We are using an up-to-date methodology. We provide comparable figures across 18 countries and hundreds of domains. We want to annually update the methodology with gathering continuous surveys across Latin America. And of course, we are in the 2020 census round, so census counts will be updated every year for the countries that make new censuses. So I'm going to show you here how we develop this methodology, and this is the map for Latin America. Here you have a whole continent. This is South America, this is Central America, and Mexico. And this map is about mean income from Colombia to Chile, from Mexico to Panama, taking into account the Dominican Republic. Here you have the map for poverty. This is mean income, this is poverty, and this is extreme poverty. And of course, we are not only interested in large, I mean, in states or geographical domains, but we need to make like a zoom in into the country. So, for example, here you can see what is happening by ethnicity and education. In the first row, you find indigenous people. In columns, you can find education. Here, no education, primary education, secondary education, and university and college. And you can see how the mean income moves, and you can say, you can make a deeper analysis. So here we have the same figure, the same domains. This is mean income, this is poverty, this is extreme poverty. Here you have the case of Mexico, but of course we have maps from 18 countries that are updated in an annual basis. If we want to go deeper under the right conditions, that means a census that is close to the survey, we can go deeper at the municipality level. Here is the example for Colombia, Chile, etc. So this is Peru. So thank you so much for for having us in this side event. If you have some doubts or comments, do not hesitate to write to us. I am Andres Gutierrez, but this work has been developed in the statistics division of ECLAC. Thank you so much, and thank you.
Thank you so much, Andres, for sharing the poverty mapping in Latin American unit level, and also how the data has been disaggregated by different disaggregation characteristic for this poverty indicators. So without further ado, I would like to invite the next speaker, Mr. Paul Corral from the World Bank. Paul is a senior economist in the West Africa region of the Poverty Global Practice at the World Bank. His research interests centered on small area estimation methods and policy applications, rural development, and human capital accumulations. So Paul will present the most recent poverty mapping and guidelines of the World Bank. The floor is yours, Paul.
Thank you, Yomi. Good morning, everyone. Can you hear me? I hope
Yes.
everyone can hear me.
Yeah, I can hear
Awesome.
you, and the slides is fine.
Awesome. Thank you so much, Yomi. So I believe it's a bit early to get into technical matters, so I apologize ahead of time. So today's presentation draws upon the recently completed poverty mapping guidelines we've put together to assist World Bank staff as well as NSOs in their pursuit of small area estimates. As you can see, I'm sorry, I need to share my screen yeah, I'm sharing my screen now. Apologies. All right. So as you can see, we've worked with Professor Isabel Molina to put together the guidelines, who is one of the leading experts in this area. The guidelines also offer plenty of examples and codes for readers to replicate and better understand the methods. And so we will be releasing these in a couple of weeks. They're just with the editing team going over typos and stuff like that. But the guidelines are basically finished. And what I am presenting today is some excerpts from those guidelines. So in the common small area estimation methods like Elber's Landau, and Molina and Rao's EB, including the Guadarrama method that Andres just presented, they make use of survey and census data. And so we aren't directly estimating poverty. So the model isn't directly estimating poverty. Instead, what we attempt to estimate is the entire welfare distribution, right? And so from that welfare distribution, we want to see how many people fall below a defined poverty threshold in each area. Hence, what is important under these methods, and what I'm getting at, is that when we combine survey household level and census data, is how well you replicate the welfare distribution. when you can't properly replicate the welfare distribution, for example, when you lack household level characteristics, then household level welfare will be poorly replicated. And we need to rely on different methods to obtain small area estimates. One such method would be the one that, similar to the one that Veronica just presented, which is an area level model like Fay-Harriott, where we directly estimate the parameter of interest. In the case of Chile, it was poverty. Wait, sorry. Okay. So a statistical model for welfare will never provide a perfect fit. There's always going to be some noise. So to replicate the entire distribution, we need to make assumptions about this noise. And this is related to also to what Andres was presenting. One of the main assumptions in the methods we often use is that the errors are normally distributed. And deviations from this assumption can lead to considerably biased estimates. As you can see here, they're all doing a different transformation. So on the left-hand side, you have the box Cox. In the middle, you have a knot log transformation. And in the right-hand side, you have a knot log shift transformation. And so we can see that not ensuring the model's assumptions hold, we risk getting biased estimates. Here, the x-axis shows a different poverty line. And so I've obtained estimates for 99 poverty lines, each corresponding to 99 percentiles of the welfare distribution. Each line, on the other hand, represents a given area. So these are our small areas. The y-axis is the empirical bias. So in this experiment, I have the truth. I know what the true poverty rate is for every single area. As you can see, the wrong transformation here may work for some poverty lines and may be completely off the mark for others. So for example, for the knot log shift, you can see that it'll work at around the 8% poverty line, the 8th percentile. And it may also work relatively well at around the 75th percentile. And the box Cox also seems to work for a couple of lines. On the other hand, the knot log, which is the correct transformation here, yields the lowest bias for all the lines. And you can see that how it works, and it's all nicely clustered around that zero bias. And so why does this matter? Well, if you want to get poverty, an extreme poverty or vulnerability from your poverty mapping exercise, it may work for one line and do very poorly for another line, right? If you want to get estimates under the same model for different lines, it should be able to replicate the welfare distribution as best as possible. So when the survey and the census data come from different periods, unit level small area estimates may be biased. Why? Because you're not using the same information. And since characteristics which were related to welfare may change over time, the welfare levels may also change over time. For such instances, the de facto approach are area level models, such as Torabi and Rao's sub-area models, or the Fay-Harriott model that Veronica presented for the case of Chile. The problem is that there are no current software applications for Torabi and Rao's method. As far as I know, there may be something newer. Last time I checked, there was nothing. And so there's also an alternative that was proposed by Nguyen, where he models household level welfare using only area level characteristics. Now, this is problematic because without providing covariates that explain variation of welfare between households, then every household in a given area is just as likely to be poor, and you fail to replicate the welfare distribution. So for all census years, area level models are still the best choice. An area level model such as the Fay-Harriott also have their drawbacks, as Veronica noted. So here, basically, I had to fit a different model for each of the 99 percentiles. For each of the Fay-Harriott models here, there is one model. So for each of the lines, so 99 models in total to make this graph. And it's not always easy to find adequate covariates for the model. And it won't be applicable for areas where the sampling variance of the direct estimate is 0. However, It is less biased than unit context models, so those that rely on household level welfare using only area level covariates, such as GIS information or stuff like that. And so these models are, Fay-Harriott models are preferred over unit context models. So there's nothing new here in that sense. So they are less biased than unit context models like those of Masaki et al. And Nguyen. And they also lead to less noisy estimates. So here what you can see is the empirical MSE under each of the poverty lines. As you can see, our traditional census EB method is the one that shows the lowest noise, followed by the Fay-Harriott, which although it is noisy, it is less noisy than those from the unit context models. Now, the Fay-Harriott have an advantage that you rely on a lot less information. So you can produce estimates more easily than under other unit level methods. Now, what about machine learning approaches? No, so we using satellite-derived data, which seem to have become quite popular recently. Well, what we find in some preliminary work is that they seem to work relatively well. These are similar to area level models in the sense that they model poverty at an area level, either PSU or municipal level here. And so for satellite-derived data, due to the structure of the data that we have, this is all done for a validation using Mexican Intracensal Survey as a census. We are only able to use satellite-derived data at the municipal level. So this validation differs from those done by those who use machine learning approaches because we validate against the truth, not the survey, right? So I have the census truth and I validate against that, not the survey, because the survey, although unbiased, is quite noisy, and it is not the right target we should validate against. No, there is a reason why we do smaller estimation is to improve on the quality of the survey parameters, of the survey estimates, sorry. So as we can see here, the method works when you look at the mean squared error, the empirical mean squared error. The method works, so the extreme gradient boosting, those in the red square, but it depends on the quality of the data you have at hand. It is incredibly important. The quality of the data determines everything. So GIS data on its own is not great and yields very noisy estimates. However, even at the municipality level, census aggregates work very well. And in the case of the Mexican data we have at hand, it yields estimates that are competitive to those from our preferred approach, census EB. They also work considerably better than unit context models we saw earlier, right? And so as noted in the previous slide, the method works best with census aggregates. In fact, when using census aggregates and GIS features, the census aggregates tend to outperform the majority of the GIS covariates. Since the empirical MSE shown in the previous slide is lower for the extreme gradient boosting models with only census aggregates, we can conclude that in this scenario, these provide much more information for the model than GIS data. Okay, so GIS is useful. It fills a gap when there is a gap. But if you have census level aggregates of stuff that is related to welfare, such as the average share of the adults in the population who have secondary education, even if dated, will always be preferable to model welfare than the slope of the terrain in a given area. Okay. And so with that, I wrap up on just some concluding remarks. I think it's very obvious, not just from my presentation, but also from what Andres and my other colleagues have presented. We need to ensure that the model assumptions are met, that these hold, right? This will ensure that we get unbiased estimates, not just of poverty, but its estimated noise or the mean squared error, right? And under the Fay-Harriott models, the best linear unbiased predictor although it doesn't require normality for unbiasedness, the normality is usually necessary for its noise estimation under the Prasad-Rao MSE estimates. And so for off-census years, which is what a lot of us care about because we only have census every 10 years and we have more frequent survey data, I think we still need a lot more research. And although we're making progress, We just don't know how well the method may work with other data. Thank you.
Thank you so much, Paul, for sharing the latest PowerPoint guidelines and by reviewing the pros and cons of different methods, and also provide cautious using some of the newest methodology, and particular focus on the quality of the data used. And thank you so much. I will invite the last speaker, Ms. Howie Chen, and Howie is the coordinator of Intersecretariat Working Group on Household Survey. Howie will present focus on building capacities on small area estimation for SDGs, and she will focus on a toolkit and a learning course. The floor is yours, Howie.
Thank you so much, Yongyi. Thank you so much for inviting me to the side event on small area estimation. Hi, everyone. Today I am going to, next slide, please. Yeah, this is the outline of my presentation. A few words about the Secretariat Working Group on Household Service, because I'm currently coordinating the work. And then I'll go straight into the toolkit on small area estimation for SDG indicators that will be released later Friday this week. And then capacity building activities on smart estimation. Just a note here, we are working with all our partners, so I will acknowledge their collaboration when I get there. Next slide, thank you. So a bit about the Intersecretariat Working Group on Household Surveys. This is a group that was established in 2015 under the aegis of UN Statistical Commission, with three main objectives. And the first one is to improve coordination of household surveys at national, regional, and global level. And the second one is to really advance cross-cutting survey methodology, and smart estimation actually falls pretty much under that objective. Is we're really identifying scalable innovations in survey methodology, and also in integrating survey with other data sources, and then bring them to countries. Experiment with them, and then hope that they will eventually go to production for official statistics. And the third objective is of our group is to enhance communication and advocacy for our work, but also very importantly is to advocate for still the importance of household surveys. And our group consists of 11 international agencies and 8 member states. And the Secretariat's UN Stats Division, and currently our co-chairs, the World Bank and UN Women. So we organize our work through time-bound task forces, led or with contributions from members and non-member experts. Next slide, please. So I'm not going to repeat what many speakers have already talked about the 2030 agenda, why smart estimation is so important for SDG data disaggregation. Yong is leading the work on the IAG SDGs, and smart estimation is also a work priority under the IAG SDGs. This is why we work together on a smart estimation, our group and the IAG SDGs. Next slide, please. So there are, I will talk about the toolkit, and also I move on to the e-learning on the last slide. We are, UNSD has been working on a smart estimation toolkit for SDGs under the guidance of IAG SDGs and the Intersecretariat Working Group on Household Surveys. A few features here of the toolkit. Of course, there is a guidance on smart estimation methods, the latest methods, software, and then we're not going to details of each method, but instead provide a lot of references to existing methods and papers, case studies over there. So we hope this is a comprehensive place that you can look for resources. And we are really offering practical guidance, and I'll talk a bit in a second. And also country case studies. We've been talking to countries and then learning from them what are the work they've been working, what are the things they've been working on smart estimation, and what worked well, what didn't work well, and we document them together with our countries. And so it's really to foster an exchange of experiences across countries. And we also are hoping that to provide a space for our partners to document and disseminate their smart estimation methodologies, to really make them the methods transparent and also easy to find in one single place. So the toolkit is hosted on Wiki platform, and that means we have room and space to keep updating it, and then also keep the collaboration going. Next slide, please. So this is how it looks like, and we have a group expert that have been supporting us, and it's on the wiki site page, and which will be public in a few days. This is how it looks on the firm homepage. Next slide, please. I'll give you some flavor of, and this is what's on the wiki site. And so, of course, we talk about the importance of smart estimation for SDG data disaggregation. As you have seen earlier, that for even one single indicator, it takes quite a bit of effort to produce the right smart estimation, SAE methods, estimates. So we felt the SDG indicator list is a really focused list of indicators that country could really make their efforts, because it's not possible to produce SAE for thousands indicators. But if we have a list as a guiding, like SDG indicators, and it's really useful. And then we have a big section on producing practical guidance on producing smart estimation throughout the stages, various stages, and all the speakers have gone through. And we talk about communicating. How do you communicate the estimates and the methods to different audiences? And then we have, I'll show you, we have a page on showing the case studies that have been used to produce indicators on the different SDG goals. And there is a section on smart estimation from experiment to production. If you have tested method, how do we move to official data production? As the practices from country, we have a lot of countries case studies, and we have software packages in a separate place, and key readings, and then international national smart estimation projects. There is FAQ. We have been collecting questions like this through venues like this, and then we put it there, and then we reach out to experts to respond to these questions. Next slide, please. So we do have really useful is we have 3 examples or case studies that that sort of go. It's being used throughout the entire wiki site. So it goes through every steps, and then we'll discuss. So when we talk about user needs, and the same example show up, and then data availability, the same example. So it's almost like showing how to do it with 3 examples throughout the entire guidance. Next slide. This is what I've referred to as the case studies covering different SDG goals indicators, and we are bringing case studies under different goals. And as you can see, there are some that we don't have anything yet. So if you have case studies examples, please feel free to share with us so we can include them. Next slide, please. So this is one aspect we've been working quite a bit, is while we're working with our countries and talking to them about smart estimation, they have been using, it occurs to us there are a lot of challenges in really moving from experimenting with the method to eventually producing the data for official production for policy making. So we have been documenting what we've learned from countries, what worked well, how come they were able to start using SAE for official data production, how come some couldn't do it. So what are really the important elements? So I've seen a lot in the chat. It's, for example, the importance of input data. So what are the key factors? And then let me move to the next slide, please, because I have some examples. There are challenges we learned from countries. For example, usually there are a lot of hesitance in using model-based estimates in comparison to design-based estimates. Next slide, and the next one. Yes, and it's useful, it's helpful if there is a legal mandate to use more disaggregated data through smart estimation. I hear echoes, but it's not always the case. And then it's also useful really to build a team around. I mentioned input data. Access to data is important, and many NSOs do not have access to administrative data. So all we can use is census and data quality. I mean, it cannot be emphasized enough. You have seen on the chat, in the chat. And how do we work with collaborators? It's actually a huge project. You need a lot of people and from different areas of expertise. If you are using geospatial data, even without geospatial data, you will need to understand how to work with the geospatial experts. Other government agencies, if they are providing one of the input data, and then you will need to work with them. And researchers to understand what kind of auxiliary variables are important for the modeling, and also whether the models work or do not work. And there's importance of quality standard. How do you ensure the quality, and then the importance of evaluating your estimates with external experts. Next. Yes, we also document by talking to countries what the best way is to build capacities. So we have written over there on the wiki. I'm not going to review everything. Yeah, next slide, please. So here's the examples we put there. We extract a lot of discussion with our countries, and we put it there. We're hoping that other countries can learn from each other. Countries can learn from each other. Ari, I stole a screenshot from you from Indonesia. So the roadmap that our colleagues from Indonesia has been building for on smart estimation. Next, please. Yes, so there is a space called SA practices. So we have been talking to country and document their work on smart estimation. So you will see we have more countries now over there, and we will because this is a wiki as I mentioned earlier. So we will continue to update this information from countries. So if any of you is interested in working with us, please reach out to me, and then we can work together to produce a space for your country. Next slide, please. So we have done quite a bit of consultation with experts in different from different places of academia and also countries. We have our next steps. We are going to release the first stage of the toolkit later this week. After that, we'll advertise the toolkit and we'll organize meetings. And so more people and more countries will be able to use it. And again, we're approaching more countries, excuse me, and document the challenges and lessons learned. So if you would like to work with us, please reach out to us. And we are going to organize small technical group meetings, discussion to really discuss specific challenges. That if you have anything that you would like to seek assistance and expert suggestions, and please reach out to us and we can connect you with the experts. Capacity building. Okay, this leads to the next slide. Thank you. E-learning. So in collaboration with our partners from Andres from ACLAC Statistics Division and also colleagues from UNFPA, we are working on an e-learning course on smart estimation. And the course includes reading materials, and we will have more than 50 videos with each about 10 to 15 minutes and organized under 10 modules. And the e-learning course will cover really the foundation of smart estimation. We are also inviting countries to present their experiences. That's for the last module. So it's a bit of, there are the foundation, but we're also inviting countries and new initiatives. We are going to we are having evaluation materials like the quizzes and then projects, and then our students or trainees can use. And so the e-learning will be using our for the programming. we will have two modalities. One is the self-paced learner. So the e-learning courses will be completely free. If you are learning on your own and at your own pace, we understand it's a lot of work. 10 modules and greater than 50 videos. You will be able to access to all the learning materials, including the projects, an R code and everything. The only thing is we are not grading, so there will be no grading. And we're also offering guided learners. There will be a tutor or teacher there really guide you through after your self-learning, watching videos. There will be Q&A sessions working with you, and also hands-on programming sessions, and then your assignments will be graded. Yeah, there will be feedbacks and grading for all three projects. Next slide. Yes, that's all from my side. If you have any questions or would like to work with us to bring your experience to the wiki and to our work, please reach out to me. Thank you. Thank you, Yoongi.
Thank you very much, Howie. And while I'm trying to provide additional information, if you have a question for all the 5 speakers, just please type it here or raise your hand. There's a function to do so. Just want to add it that the wiki website will be launched later this week, but you can take a look of the outline of that toolkit. I think it's already available as a background document for the IEG SDG paper. So it's available on the Statistical Commission website. So you can take a quick look of the outline of that toolkit that we provided. So I see one question on how can we join e-learning courses? So this is a question for you, Howie. So I would like to invite our speakers maybe show their screens.
Quickly, so once it's available, it will be hosted online. We'll share with all the share link with everybody. We'll really broadcast it. For the guided learning, and because it does require resources, we'll be running courses over the year as resource becomes available.
Yeah, thanks, Howie. I think ICLAC are already running their own courses in Spanish, so that's already a lot of country has been trained. Andres, do you want to provide additional information on the courses? No. Okay, okay, I'll see you now.
Not much, but everyone is welcome to join this effort of e-learning in smaller estimation. Just that.
Yeah, I also like to thank Veronica, Paul, and answer some I think all the questions on the chat. If I don't miss any. Yeah, and also Ari to answer the questions on the chat. Thank you so much. And I think we have 5 minutes left. I probably will give one of you 1 minute each to talk about what's the most important things from your country experience or working with countries on using small error estimation. So maybe I will start with Ari.
Yoongi. Sorry, Yoongi. Please repeat. Yeah.
I'll repeat myself. I just want to give each speaker 1 minute time. What's the most important thing you think when applying smart estimation?
Yes.
I know it's very short to summarize this very complicated technology, but we'll be probably just we don't have much time left. I just want to have one thing that from your country experience that you want to provide to other countries.
Yes, the important thing is how to build the good team in small area estimation, and we have to keep study for the theory of the small area estimation, and we have to take care more about the data characteristic is very important because will be different from every area, will be different the quality of data characteristic, and we have to develop the survey and census with high quality data, high quality assurance. So if we can use the data for SIA estimation, I think that's the point from our experience in small area estimation. Thank you.
Thank you very much, Ari. Then we'll invite Veronica share the, like 1 minute of the most important thing you think in using SAE method.
Thank you. I think I agree with Ari. The most important thing is about building a team. We are 3 people working on this project, and we are also very grateful on the advisory we received from ECLAC, Andres Gutierrez, and the other consultants. Another 2 important things to take into account is the data you have available to produce this estimation. So to decide if you go with a unit level model or an area level model, you need to evaluate the data you have available. So that's all. Thank you.
Thank you, Veronica. Andres?
Well, I think that for me, from my point of view, the most important thing is to understand the nature of a random effect, because behind that is the reason why we are modeling the way we are modeling data. And the connection between a random effect with a survey that do not achieve all of the consistency and based on properties that we want in a direct estimate, it's really important. So first of all, trying to understand what is the difference between a random effect and a fixed effect, and going deeper into the nature of a random effect is definitively an important thing to take into account.
Thanks, Andres. Paul, you already answered in a short summary, and maybe you can elaborate a little bit.
Thank you, Yumi. I really don't have anything to add on the excellent points made by my colleagues on the technical side. What I think I would emphasize is the power that these estimates have. No, that they can improve targeting efficiency greatly. And so it is great that the statistical agencies do this, but hopefully these do not end up in a room in a computer locked where no one else has access to these. Make these public, share them with others, make sure that the other ministries know of these, that they can use them for their programs. So put it out there, make it public. That's it. Thank you.
Thank you, Paul. And Howie, you're the last one.
I would like to bring us back a little bit. Definitely echoing what Paul said, bring all your estimates to the ministry so they know about it, and also document what you've done. If the ministries use your numbers for any policy makings, write it up and bring this to the whatever Ministry of Finance for funding to support your work. Just one thing, SAE is very powerful, but it's not a solution for everything, because when you carry out a survey, you can generate data for thousands of indicators. And for smart estimation, for one indicator, you need a lot of work. So you need a lot of resources. So it's very resource constrained. And so just think it's not something that you can just do it for all possible indicators and you are going to have this disaggregated data for everything. It's not possible. It's just not realistic. So one thing is to understand the limitation of smart estimation, that you will have to be very focused. It requires a lot of resources, requires a team, as Veronica and Ari both mentioned. And then when your data are being used, document them and bring them to convince the policymakers you need additional resources to work on it. Thank you.
Thank you so much, Hao-Yi. This is a really great lesson, and this is a really powerful tool. SE is a really powerful tool, but it's not the solution for all, and it's really resource intensive. And we just want to inform everyone that all the presentations and also recording of the event will be made available shortly on the event website. And I would like to thank very much to our presenters for sharing the excellent knowledge and experience in the area of using small area estimations, and also for thank you for answer the questions. And this will be really helpful for the future work in small area estimation. I would also like to thank those that attended this side event. I maybe will invite everyone, if you can find at the bottom there's a reaction button, so give a big plus to our other speakers. So thank you everyone, and thanks again for attending this event, and I'll see you soon at other side event of the commission. And thank you.
Thank you. See you.
Thank you.